Hi, my name's Owen Gibson, student number N99362238, and this is my response to tutorial 4 for EGB345. So as you can see in the PDF before me, this is the question that's been given. The question is to find a transfer function theta L with respect to EA, where theta L is a rotational motion of JL, and the mass here, and EA is the voltage dropped through the circuit. I'll now go across to my answer. So the first thing I did was redraw the diagram. The key difference here is I've included JA. JA is the mass of the armature in the motor. I've then redrawn the circuit where I've transposed JA to the other side of the gearbox, and the necessary steps have been taken with respect to multiplying by N1 and N2 here. Torque multiplied by N2 and N1, and rotation theta is multiplied by N1 and N2, and the weight itself of the armature is multiplied by N2 and N1 squared. I then calculated each of the forces acting on JA, the first weight. So the torque, on the left-hand side of this equation, the inertia of the mass itself, its relation to the spring, and that's the location of the spring in relation to the other object. I then calculated the sum of the forces on the second mass, JL, which is the mass itself, it's inertia itself, it's the damper, and then the two springs attached to it. I then calculated that for theta L, and was able to reinsert that back into the torque equation to get this larger equation here, which is the torque in relation to theta n. I then have the two equations for the motor, where torque is proportional to the current and voltage is proportional to the speed, or here, and I then sub those two together to get this equation. I then sub that entire equation together to get this equation you see before us here, which is EA on theta M, but I wanted to find theta L on EA, so I subbed in theta L, and I then did 1 over that equation to get the following equation down here. I inserted the values I was showing you above, and the final answer I got was 416.67 divided by s to the power of 4 plus 168.678 s cubed plus 1,113.33 s squared plus 27,083.3 s plus 3,125. Thank you.